What is up, Flutter devs? In today's widget workshop, we're going to build a neat typewriter widget, which animates the appearance of characters in a string to make it look as if a person is typing. And not just typing one message, but once a message is completed, it will begin deleting characters to type the next message. And in this workshop, we're actually going to use Flutter for web because we're going to integrate that typewriter widget within a cool marketing header for our web page. Now, as always, if you like what I'm doing here and you're a fan of Flutter, do me a favor and like the video, subscribe to the channel. I'm on a mission to try to get to 10,000 subscribers, and I could really use your help to get there. With that said, let's jump into the workshop. Here we have a Flutter web app with a kind of decorative header. And in that header, we have something that looks a bit like a terminal. And for a kind of marketing purpose, we would like to make it appear as if in this illustrated terminal, there are commands that are being typed over and over again. In this case, to advertise the different capabilities of the Flutter command line interface. And that's what we're going to build today. So let's jump in. This black box is where we would like to be able to see text being typed out as if a human were typing it. How can we make that happen? In step one, what we'd like to do is get the static pieces in roughly the right place. We're not going to worry about animations or the typing effect. Let's just figure out the overall shape of this widget that we'd like to create. We will call this widget a typewriter. And let's just list out some things that we know that we're going to want. We're going to want some concept of a prefix. In our case, that prefix is going to be a caret that looks like you're using a command line or terminal interface. But just generally speaking, we'd like to stick some kind of constant prefix text in there. And of course, we would like to be able to style that prefix text. We'd also like to allow for spacing after the prefix. This is spacing between the caret, let's say, and the command that's being typed. Then we'd like to accept the text that is being typed, and of course we would like to be able to style that as well. And we would like to accept a color for the cursor. These are all kind of obvious things we know we want even before we get to any kind of animation. So let's take all of these into a constructor. Let's also now come up here and replace this container with a typewriter widget. We will choose prefix text that is simply a caret, again, trying to look a bit like a command line interface or a terminal. The prefix text style, we will use the following settings. For the color, we will go with a relatively light gray. For the font size, we'll go with 24. It's relatively large, but we're creating a decorative header, so that's okay. We will also make the caret bold. For the spacing after the prefix, we'll go with 8 pixels. For the initial text that we're going to see on screen, we'll say Flutter create my new app. Flutter create here is an actual Flutter command, and you can pass in the name of the app that you want to create. Then for the text style, we're going to go with a font size of 20. And because I'm the one doing this, we're going to go with a yellow color for our text. We're also going to go with, we'll go with white for the cursor. We'll save that. There's still no impact because we haven't actually created anything inside of our widget here. So we have to actually put these properties to work down here in our build method. Because we want to display things horizontally across the screen, we want a prefix, text, and a cursor. What we want is a row. We can represent that relationship with a row. The children in the row, first is the prefix text. And the style is the prefix text style. Then we create a sized box whose width is equal to the spacing after the prefix, because that's the whole point of the spacing, is to space the prefix from the text that follows. Then we will display the text that we will eventually want to type, and its style is going to be the text style that's passed in. And then we want a cursor, which we're just going to represent using the vertical bar character, which is often how it's actually represented in a terminal anyway. For the style of the cursor, we're going to give it a color that's equal to the cursor color passed into the widget. And we're going to choose a font size that is equal to the font size of the text that we are typing. With that done, let's save. And now we have a static appearance for a kind of CLI interface. We have the caret here, followed by this stuff that eventually will be typed. And then there's a cursor that's always kind of at the end of what is being typed. This handles step number 1 for us. And in the next step, we're going to take this text right here and we're going to animate it being typed, starting with nothing all the way to Flutter, create my new app. We'll do that in the next step. Now let's make this command line text appear as if it's being typed. How will we do that? If it's going to be typed, it means we're going to begin with no text, and then we're going to add character after character until eventually we have added all of the characters. This means that we're going to need to know the text that we're going to type. We need to know the next index that we're going to type. So the index of this string that we're going to type next. And then we need the text that we have already typed. And if we correctly manage these 3 pieces of information, we should be able to make it appear as if text is being typed into our little terminal. Let's implement init state, where we can give these variables initial values. Text to type is going to be equal to the text parameter passed into our widget. Initially, the next to type index is going to be 0, and initially, the text that we have typed is going to be empty. And then immediately upon init state, we want to run a function that we haven't declared yet, but we want to type new text. This is our set of starting conditions, and then we want to begin the effect. It all comes down to what we do in this method called type new text. So what does it mean to make text look as though it's being typed? It means that we're going to add a character, we're going to wait for some period of time, and then we're going to add another character, and then we're going to wait for another period of time, and eventually we reach the end. That's what looks like text is being typed. That's what we want to achieve here in the type new text method. We're going to start with an initial delay. The future class has a static method called delayed, where you can pass in any amount of time you want, and execution will essentially stop right here for that period of time. Now, this is not a blocking call. Notice that we're using the await keyword. Really, this is using futures, but because we're using async await, it's going to look as if execution stops here for 1 second and then continues. We offer this initial delay so that the user has a moment to kind of see what's going on the screen before we start typing a bunch of characters. We wait for a second and then we want to start typing. But here's a really important thing to understand. Anytime that you use a delay within a widget, no matter how tiny that delay is, there's a possibility that by the time the delay is over, your widget is no longer a part of the widget tree, in which case attempting to set state will result in an error and it'll blow up your app. What we want to ask is, we want to say, if we are no longer mounted to the widget tree, we're just going to return. If we're no longer mounted to the widget tree, we don't have a UI anymore. There's nothing for us to do. We just need to return and be done. If we are mounted, then we will continue and we will type the text. We will then say for I starts at next to type index, which initially is 0. So you can kind of think of us, this won't be true throughout the entire workshop, but for now you can just think of this as being 0. I equals 0, and then we start typing. As long as I is less than the length of what we're trying to type, we will increment I. We will once again wait. But this time we're only going to wait 50 milliseconds. Up here, we waited a full second to get started, but now down here, we're just going to wait 50 milliseconds between typing characters. But again, we have to say, if we're no longer mounted, then we need to return. Otherwise, let's go ahead and type a character. We will change typed text. It will now be text to type. So text to type, that's the full message. That is, text to type is Flutter create my new app, the whole thing. Typed text is what will be visible to the user. We want a substring. We want a piece of the overall message from 0 to I minus 1. That's the substring that we want to display. And that substring is going to add a character every 50 milliseconds. And then one last change that we need to make down here is that instead of always displaying widget.text, we actually want to display typed text. Now let's save that. We need to do, let's see what the error is. I think we might need a hot restart here. We need a hot restart because we added these properties that didn't exist before. Still complaining. Let's see. So widget.text, we know we're passing in the text. Let's just output our values right here and see what's going on. I bet I minus 1, I minus 1 is going to be negative. Yeah, that's the problem right there. And that's because this should not have been minus 1. It should have been plus 1. So my bad on that. Let's jump into substring real quick and take a look at this. Returns the substring of this string from start index to end index exclusive. That's why right there. Start index, when start index is 0, we literally start at 0 inclusive. But if I put index 1 in here, it's not actually going to give me the character at index 1. It's going to give me only the character up to index 0 because it doesn't include the end index. That is why we need I plus 1. Let's save that. And there's our typing. Refresh. We'll see it again. And there's our typing. Now, where do we go from here? The thing about typing every 50 milliseconds, I mean, that's a good enough effect, but it still doesn't quite look human. And it doesn't look human because we don't type with an exact equal amount of time every time we press a key. Some keys take us longer to get to than others. We're going to add some timing variance in the next step to make this typing look a bit more human. So let's go do that right now. Let's take our animated typing effect and let's add some random variance in there so it looks a bit more human-like. In our stateful widget, let's go ahead and define a couple of constants. Let's define both the minimum and the maximum amount of time that can take place between typing characters. We'll have a min typing pause delay, which we will set to a duration of 20 milliseconds, and then we will have a max typing pause delay, which we will set to 200 milliseconds. Then down here, where we currently have a constant delay value, we will instead defer to a method that we're about to write called generate typing pause duration. That's what's going to allow us to create a different value every single time. Down here, we will declare generate typing pause duration. And now we want to generate a value between the minimum duration and the maximum duration. How will we do that? In other areas, if we want to find a place between two other locations, we use something called linear interpolation. Linear interpolation, when I originally wrote this code, there was no linear interpolation for durations. There is now because I've actually added it to the Flutter framework. I went ahead and committed it to the Flutter framework foundation code. You can find a lerp duration, which means linear interpolate duration, in Flutter, but because it's still on the master branch, I'm not going to assume that you have access to it. So what we are going to do is actually implement it ourselves. We're going to implement something called lerp duration, and the implementation is very, very simple. But the point is we're going to treat this the same way that we would treat getting a value between two doubles or a color between two colors. We're going to pass in the minimum type pause delay and the max typing pause delay. Min typing pause delay, okay? And then we want to pick a value between those two. How much between those two? A random amount between those two. So we'll import random, and we will ask for the next double, which is between 0 and 1. If a value is between 0 and 1, we can treat it as a percentage. This means we want to linear interpolate from min to max, and we want to go a random percentage between the two. This is what gives us a random value between those two durations. Now all we need to do is implement this concept of lerp duration. So we have the first duration, we have the second duration, and we have the percent. We will return a duration based on milliseconds because that's the smallest divisible unit of time available to us in Flutter, I believe. At least for durations, I think. And so now we will use the regular lerp double. We will take the milliseconds. I guess we could use microseconds. Doesn't matter. Milliseconds are good enough. So we will take the milliseconds from the first duration. We will take the milliseconds from the second duration. These are just numbers like 10,000, 10,000 and 2,000. We'll take those two numbers and we will linearly interpolate between those numbers based on the given percent. So this will take two doubles, two regular numbers, and it will choose a number in between them based on this percentage value. Of course, the number that we're going to get back is also going to be a double. We cannot represent milliseconds with a double. We need to round that value. Let's see, what's it complaining about there? Oh, because we need to actually import this, import that from Dart UI. So we linearly interpolate between these two numbers based on the percent, then we round it to the nearest integer and we pass that in to a new duration for the milliseconds. This effectively gives us linear interpolation between two different durations. And because we passed a random value in for the percent, this gives us a randomly changing number that is at least as large as this number here and no larger than this number here. And that is the effect that we want, right? So let's save that and see what kind of results we get. It may be a bit nuanced, but if you compare this to what we were seeing before, you'll notice that some characters appear very quickly and others take a little bit longer. And that gives us a much more human dynamic. And it looks a lot more like human typing. And of course, you can mess with the minimum and maximum numbers all you want until it looks as human as you can get it. But I'm happy with that. And with that typing done, what we're going to do in the next step is we're going to make it so that once you complete typing out one line, you then type out another line, and it cycles through a number of options that we want to display in our little marketing area here. We'll do that in the next step. We'd like for a number of commands to appear in our little header marketing area. We want to show not just Flutter create, but Flutter run, Flutter build. We want to show a number of different commands. So in this step, we're going to alter our behavior so that every time a line is done being typed, it triggers a new line to be typed with different content. To get us started there, we need to actually decide what those commands are that we are going to support. So up here in the widget workshop area, we are going to define a constant list of Flutter commands. We'll start with the one that we have been working with this whole time, Flutter create my new app, but then we're going to introduce Flutter run, Flutter build Android, which builds an Android binary, Flutter build iOS, which builds an iOS binary, and Flutter build web, which builds a web package or bundle, essentially. We need to know where we're starting here, so the current command index is going to be 0. And then we're going to define this method called next command, which increments our reference. We're going to rebuild our entire widget tree with current command equal to, well, first we're going to make sure, we're going to see, is the current Flutter command index or the current command index less than the length of the commands minus 1. We don't want to go past the end of the array. If there is still room left in the array, we will simply increment by 1. Otherwise, we're going to reset back to 0. Then down here in our Typewriter widget, where we pass in text, we are instead going to pass in Flutter commands current command index, which won't have any effect because the first one is the same text we were already typing in the first place. What we need to do to actually get the ability to switch is we need to support the concept of completing the typing process. That callback, once it is supported by our widget, we will invoke next command, and then it will go to the next command. But that's something that we still need to support. So we'll come down here and we'll declare a void callback called onComplete. We will take it in up here. With that void callback, see, we will come down here. Well, there's something we will have to do with did update widget, but let's get the callback working first, and then we'll look at what we need to do with widget updates. At the end of all this typing, we want to give the viewer a moment to appreciate the text. We don't want to just immediately go to the next command because we just got to the end of this command. So once again, we are going to delay. We're going to give a whole 4 seconds there at the end. And then After those 4 seconds, if we are still mounted to the tree, if onComplete is defined, if we have an onComplete callback that is provided, we're going to invoke it. So let's see what that does for us. It doesn't appear to do anything for us. And why is that? The reason that there's no visible change is because in init state, we determine that the text that we're going to type is set to the original text passed into the widget. We never update this. So the text that we think we're trying to type never changes. And that's why we need to implement didUpdateWidget. If widget.text, meaning our current widget text, is not equal to the old widget's text, then it has changed, and we need to change our text to type to equal our new widget.text. We need to reset our position back to 0. We need to reset type text back to empty, and we need to start typing all over again. Now let's see what this gives us. All right, now we're cycling through. Now we're cycling through a bunch of different commands. We have human-looking typing speeds as it goes along. We're getting to a pretty good place. One thing that I still don't like about this is that every Flutter command begins with the word Flutter. When really that's twofold. The first thing is that you can't really just get rid of a line in the terminal the way that we're doing it here. And part of that frustration is also that the beginning always stays the same. It's always Flutter. It would look a lot more natural if it appeared like we were backspacing, if we were deleting what we had typed all the way back to the point that it says Flutter and then type it out again. That would be a more natural way to show this kind of effect. So starting in the next step, we're going to make that happen. Let's implement the ability to erase text before we start typing new text. One thing that I'm going to do right off the bat is I'm going to take this ability to type the text forward, and I'm going to actually move that into its own method called type forward. So I'll cut that, and we will await type forward. Let's go stick it in a method called type forward. The reason I'm breaking that out is because we're also going to define a somewhat similar inverse method called erase to index. Given where our text is right now, we're going to erase back to whatever this index is. How do we know what index to erase to? We'll figure that out in a minute, but first we want to be able to actually erase to the index. So from I equals typed text.length, that's the text that we have already typed, -1. While I is greater than or equal to the index that we're trying to get back to, we will subtract 1 from I, or subtract 1 from I. We will await, once again, we want that delayed effect. Now, because, once again, emulating human behavior, if you're just holding on the delete button, you actually are going to get a pretty consistent duration on the time it takes to delete a character. So we're going to go back to hard coding here at 40 milliseconds. After that delay, if we're not mounted, once again, we're going to return. Otherwise, we're going to set state. Typed text is equal to typed text dot substring from 0 to I. and the next index to type is now equal to I. This is us shortening the string one character at a time. And this is us saying that like whenever we stop shortening the string, if we want to start typing again, here's the next index to type. Given that we're now going to start erasing text when we switch the commands, we don't want to reset everything here. We don't want to reset the next to type index, and we don't want to automatically go back to an empty string. We do, however, want to update the text to type. Now here in type new text, we have type forward, but type forward shouldn't happen until we're done erasing. Up here then, above this, first we want to find the first different character. This is not something we have implemented yet. But given the previous command that we typed and the new command that we want to type, so given the text to type and what we have already typed, we want to compare those two strings and we want to find the first place where they are different. That's how far back we delete. We haven't implemented that yet. We will in a moment. But once we've found that character, then we want to erase to that index. We want to backspace, delete back to that index. Now that's going to take some time. So once again, we want to say if we are not mounted, then return. Otherwise, begin typing forward again. So theoretically, as long as we can implement this method, we should be able to get deletion and then typing forward and then deletion and typing forward. Given label 1, given label 2, we'll start with index equal to 0. And while index is less than label 1 dot length and index is less than label 2 dot length, and label 1, the character at index, is equal to label 2 character at index, we will increment index by 1. This is the part that matters the most right here. This says if the characters in both strings are the same at this index, then clearly the strings are equivalent up to that point. So we'll go to the next index. Now notice, just to be clear, by having index plus 1 here, the index that we return is the first place that they are different, not the last place that they are the same. It is the first character that is different. At the end of this, we return index. With that done, let's see what we have here. So that's what we expected, and that's looking pretty good. We're getting very close to having the effect that we want. The last thing that we really want to work on is the cursor here. We want it to blink. So in the next step or two, we're going to get the cursor the way that we want it, and then we'll be all done. So let's get into the next step. Let's finish up here by getting the cursor effect that we want. And the first thing that we're going to do with our cursor is we're going to extract it as its own widget. That'll be a starting point for us. Up here where we configure our typewriter, or I should say actually in our actual widget where we have this text here with this bar for our cursor, let's go ahead and yank that out of there as a widget called blinking cursor. And I'll show you one way to do this within the widget tree is to right click, go to refactor, extract Flutter widget. And we're going to call it blinking cursor. Now you'll see here's blinking cursor. We do need to do something about these parameters. But then down here we have this blinking cursor declared. So this, I'm not sure what went wrong here with the generation, but we want font size here, and we want color here. And yeah, we do want to require these parameters at all times. So that's fine. And then back down here, we want color and we want font size. Now, because we want this widget to blink, let's also, I guess, fix this. Because we want this widget to blink, we want it to be a stateful widget. So I will option enter on the stateless widget, and I will say convert to stateful widget. Now we have ourselves a state object down here. And now we are in position to actually figure out how to make this thing blink. First, let's get an animation controller set up here in our blinking cursor state and just get it to animate back and forth, in and out, and then we'll take it from there. We'll mix in a ticker provider state mixin. We'll declare an animation controller. We're also going to define a constant pulse period. So we're going to pulse in and out, and we're going to go with a duration of 400 milliseconds. Let's define a init state. And then let's instantiate our animation controller. We're going to add a status listener. If the animation completes, then we're going to reverse it. This is what gives us the pulse in and out. When it completes, we reverse. When it gets back to 0, we move forward again. So when we complete, we want to reverse. When we dismiss, that's the same thing as coming back to 0. We want to start animating again. And we want to immediately start this effect in an init state. So we will go ahead and start animating right here. Now we have to actually apply this animation, as always. We will surround our text widget, our subtree here, with an animated builder. For the animation property, we will pass in our animation controller. And then we will take the color of our cursor and we will give it an opacity that is equal to the animation controller dot value. That begins transparent, then it goes to opaque, then it goes back to transparent. And one thing before I forget, because we have an animation controller, we do need to dispose of it. Let's save that. And you can see that the cursor is, in fact, blinking. That's a good start. The one thing that we don't quite have right is that every time the user taps, it should start over immediately. Like while the user is typing, the flash of the cursor should be based on when the character is actually typed. It shouldn't be a constant flashing in and out. That's more of an idle effect. So the question then becomes, how can we tell this cursor to reset its animation every time a character is typed? Well, there are a number of ways to go about this. What we are going to do is we are going to introduce the concept of a blinking cursor controller. And we're going to mix in change notifier, and anyone can call reset. Anyone that has access to an instance of a blinking controller can call reset. And what we're going to do inside of our widget is listen for any changes. And every time a change occurs to this blinking cursor controller, we're going to start our animation over again. What this means is that we need to take in an instance of cursor controller into our blinking cursor widget. Then here in init state, after we get everything set up, we want to say if we were actually given a controller, then we want to add a listener to that controller. We haven't implemented this method yet, but we're going to implement a method called reset. So every time the controller changes, we want to reset our animation. How do we do that? Well, we'll come down right here and we will create a method called reset. And all we need to do is say animation controller forward from 0, 0. That resets the animation. But there's one more issue that we need to deal with in terms of this controller, which is what happens when we are given a different controller. It's not just the initial controller that we need to worry about. What if the original controller is replaced with a different controller at some point in the widget rebuild process? In this method, did update widget, we need to say if our current controller is not equal to the old controller, then assuming that the old controller is not equal to null, we need to stop listening to it. We need to remove ourselves as a listener. And if the new controller is non-null, we need to add ourselves as a listener to the new controller. And to be clear, none of what we're doing here is specific to our controller. Anytime that you listen to an object that's passed into a widget, you need to do this. You need to look for any time that the object changes. You need to stop listening to the old one and you need to start listening to the new one. If you don't do this, then you'll get a memory leak here for the old one and you won't get any of the messages from the new one. This is a common thing that you do in Flutter. Now let's go up and actually make use of this capability. So we've implemented the blinking cursor part, but now we need to actually give it a controller that we can reset as needed. So back up here in our typewriter state, we will add a declaration for a blinking cursor controller. We'll call it cursor controller. We will instantiate it here in init state. We will dispose of it because change notifier needs to be disposed. So we need to implement a dispose method. And our cursor controller, we will call dispose on it. Now, every time that we erase a character or type a character, we want to reset the cursor effect, the cursor blinking. So that means this erase method and this type forward method are where we want to make that happen. So here in erase to index, this is where we create the new substring. We'll come in here and we will say cursor controller reset. And we'll copy that same line into type forward right here. And last but not least, we need to actually pass that controller to our blinking cursor. And let's see what happens. So you can see that it's clearly not just sticking to the normal blinking while we are typing. Now, one thing that I do think is happening is that because we're starting at 0 opacity, it looks invisible most of the time. And I think I might actually like for that to be the opposite. I might like for it to start at full opacity or full opaqueness. Let's see what happens when we invert our opacity here. Yeah, I think I like that a lot better. We want the cursor to be fully opaque, fully white, the moment that a character is actually typed. And only if a character is not being typed do we want it to fade out. So I'm pretty happy with that. And I think that that concludes today's workshop. We have this makeshift human typing terminal effect, which you can use for various decorative and marketing purposes. We relied heavily on widget trees in this workshop, not a single custom painter in sight. So hopefully you learned some things about declarative UI today, and I'll catch you in the next workshop.